In this session, let's discuss about like how object detection is, like what is object detection and how object detection works with deep learning. Okay, so let's start. So okay, so till now, like before object detection, what we have seen till now is image classification, right? So where what we have did, like we, in case if we pass an image to an model, okay, network, and it will classify among the object, if like cat or dog or aeroplane, so on, right? So it we are able to classify if this image contains any of this object. Okay, so in case like if there are like two objects in a single image, okay, so there is cat and there is dog as well. Okay, there is a car, let's say. So in this case, let's say we also have to it can't classify between a cat and a car, right? Like, so it will give maybe like probability which is higher, right? Like maybe zero point 0.4 and 0.45, something like this. It may give some value like this, and it will be classifying into one among them in case of image classification, right? And in case if we want to go for multi-label classification, then maybe you'll get one for both this and as well as this. Okay, this is one scenario. But actually not just classifying it, like not just detecting that there is a cat in that image, there is a car in that image. We also want to locate that image as well, like means, so here is a car, okay, so here is a cat, here is a car, something like that. We also need a kind of a boundary where this particular object is located. Okay, so this is like classification. Once it is classified, you want to locate it, right? Localization. Okay, so these are the two things, like what we need in case we want to find out if where that object is, and is that object present in that image, and in case if it is present, where that object is, right? So combining these two tasks, we call it as object detection. Okay, so what it does is, like, it in a given set of image, like it should be able to detect that object is present, like let's say pedestrian is present, and then like we also have to give their bounding boxes. We call this as a bounding box. Okay, so and this bounding box can be of two formats. One is like XYWH, or like X1Y1, X2Y2. So what are these X1, Y1? Are these enough to represent a complete box? Let's see that first. Okay, so what they'll do is, like, let's say in case if this is a box and you know this point as X comma Y. So and if you know this is your width and this is your height of your box, so what will happen, like can we also determine the other three coordinates? Can we calculate them? Let's see. So X comma, this is like Y coordinate, right? So your Y axis, let if you consider this as a kind of coordinate axis where here is 0 0, and here your X is going towards this x-axis, and this is your y-axis, right? So actually this is a kind of a matrix where you have 0 0 here, and then as you move on, your value, column value will increase, and one other way, like row value will increase, something like that. Okay, so this will be here, it is, if you represent it by height, it will be like y plus h. So here if you represent by width, it is w comma, so just a moment, let me not put this, like just for an example I have given it. So can we have something like this here? So and y, so here your y axis did not change, right? So the direction, vertical direction is same. So and here what you can have is x plus w, y plus h. So this is how, actually, just by knowing these four coordinates here, you were able to determine the entire bounding box. Okay, all the coordinates of bounding boxes. So so what we can do is we can represent our bounding box just by using xy and wh, but this has one small assumption that these will be in rectangles, right? So your box, if it is something like this, so this is not what actually it will be able to represent. It will be able to represent only in case these are like straight. This is also straight to x-axis and y-axis. Then only it will be able to represent it. Okay. So this is one assumption which it will take. So this is how x, y, double h. In case if it is x1, y1, x2, y2, what does it mean is, in case if you know the width x1, y1, and this is x2, y2. Okay, by knowing these two, what you can know is like you will also be able to know this width and height, right? So because like this is x1 y1, this what it will be like x2 y1, because it's only moving in x-axis. And here if you see, it will be x1 is moving, not moving at all. This is like x1, let us say x2, this is y1, this is y2. Oh sorry, this is y1, this is y2. So if you see that, if you can see the coordinate axis here, y2, x2, y, right? So just with these two coordinates, you are able to determine the bounding box again, right? So it's the same way, like either one of these can be used. People usually like this is more used way of representation where we use x, y, wh. So let's use the same. Okay, this is about bounding box. Now let's move forward for solving an object detection problem. So what actually object detection means and so on. So now for formulating a problem here, so what does it need? So outputs of object detection. Okay. So what does it need? Like one thing is like object classification, right? So for this object class means like you have a class probability and so on, right? So similarly, along with this, you will also need a bounding box. For localization, you would need a bounding box. Okay. So here is a class, let's say C. Here it's WYH. So total we need 5 inputs for one detection. Okay. So in case if you have a model here for which you will be passing an image, so at least you need like 5 uh, outputs, H and C. So but if you see here, this C is a classification, right? So it's just every class, it's like any machine learning classification model. So what you have is you have to classify between different classes, like maybe dog, cat, aeroplane, car, pedestrian, and so on. Okay, so this is a classification type. And if you see these four, these are like continuous values, right? So what you have is a bounding box which contains these values, WH. So these contains the values of these values, right? So it means you need to predict a continuous value over here. So what is this? A regression model. This is a classification. So within your object detection problem, you have to solve like both kinds of problems here. So one is like a regression problem, and one more is a classification problem. So your loss function should also contain. So what it should have is it should contain regression loss, plus it should also contain a classification loss. So this is how it should be. And what people do is like instead of just adding it in same way, you can also have kind of a hyperparameter with which what you'll do is you will kind of weight these methods, like maybe W1 regression problem plus W2, or maybe 1 minus W. People also use lambda here. Okay, so lambda into this one classification. So actually what this lambda and 1 minus lambda will do is, in case if your lambda is between 0 to 1, So if you want lambda equal to zero point 0.4, okay, let's say that way, zero point 0.4 into regression loss plus 1 minus zero point 0.4 is 0.6 into classification loss. So this is what you'll have. Okay, so it means you are taking this as 40%, this as like 60%. So you can actually determine like how much is a loss function. Usually in case we want to keep both as same, like you can keep lambda is like 0.5. Okay, so this is how usually like you can scale between, like maybe do weights between your regression and the classification loss, and the combined loss you can optimize it. Okay,